data management. Have been for 4 or 5 years now. And this is sort of, data management is sort of in transition now. I'm going to cover what is now. We're hoping that within a year, much of this changes. We'll have to give you another tutorial next year. But the goal is to try to learn what the data management plan is in the software for DUNE and how you can use that, particularly when you're running jobs. Well, I mean, this is what we're building towards is the idea of data sets and how we run jobs, et cetera. The sequential, I am sorry, there is actually a typo in our, tutorial, and I'm not sure how it got in there. SAM does not stand for the sequential lattice model. It stands for sequential access with metadata. And it was originally developed for D0 in the very late 90s. It's undergone some number of changes and simplifications over the years. It's a data handling system, but it's more than a data handling system. It's also, I mean, why was it developed? To have a data management system also tries to tell you who made this data, when was this data made, how was the data made, with what application was the data made, what trigger, what, in the case of Monte Carlo, what version of Monte Carlo, what type of data is it? Is it raw data? Is it Monte Carlo data? Is it from the detector? Is it from which detector? DUNE, we have already at least 10 different data types defined, both current proto-DUNE detectors and future real near and far detectors, 3 different near detectors, 4 different near detectors, as many as 4 different far detectors. So we've got a lot of complexity already in the system. So when you see this once per session setup SAM web client here, this presumes that you've already done all the other setups of DUNE data that was there. You don't need to set up DUNE TCP to do this, but you do need to source the DUNE setups for this to work. Presume you already did this in the previous tutorial. So SAM is a unified thing, and it actually has got 3 components. One is it says to track the locations of files. The second one is to track the metadata about the file. And the third one is actually to deliver those files or to the job and to make sure that when you've processed your data, once you process the data, it keeps track of the fact that you process the data and it will give you the next file. So typical DUNE computing will run over a whole data set of jobs. And when you run a DUNE job, you don't say, I want to access file number 3959. You're going to have a whole batch of files and you're going to say, give me the next file in the data set. And that way you'll keep on running jobs and keep on asking for the next file in the data set until you run out of files, basically. That's how it works. The SAM web client is the command line tools. You've heard some about Rusio. Rusio is not yet in production, but I'm just going to mention it because it is coming. Rusio is a data replica service and it's part of the new DUNE distributed data management system that's currently in deployment. So we the data handling experts are using Rusio. DUNE has computing centers all the way around the world. I mean, we're in Brazil, we're in India, we'll soon be in Korea. We have several locations in the United States, and we have big storage and compute contributions from the United Kingdom, several places in the United Kingdom, Netherlands at NICAF, Spain at PIC in Barcelona, the Computing Center of France at Lyon, and then also obviously at CERN, and also at Prague. So we have about 15 remote storage elements all the way around the world. We already are using Rusio to get data from Fermilab to all those other places. But the typical user does not yet have to handle Rusio. And we're hoping that once we do put it in place, we're going to have things that are compatible to the current SAM client so that people's job workflows who are used to using SAM can transparently go through without any much question. So I gave you some examples of Rusio things. You will not be able to run those. most DUNE people are not yet able to do Ruthio client, and we also don't distribute the Ruthio client yet in the DUNE software. So enough about Ruthio, but it's coming. Why are we going to Ruthio? Because Sam once had all the things to get data around the world. Most of that functionality has now been taken out, so we need a better way to do it. And Ruthio is used by a lot of other experiments. We're not on our own there. It was originally developed for Atlas, but it's since been adopted by CMS and also by DUNE, and also by the Vera Rubin Observatory, otherwise known as LSST. So there's a wide range of adoption there, and the community is moving towards a common solution. So the last exercise Kirby gave you was IFDH locate some file name. That was actually calling SamWeb underneath the covers here. It was transparently setting Sam here. So Sam has a location. I don't think I said here, if you say SamWeb help commands, it will show you all the commands that SamWeb could do, but one of the big ones is dealing with file locations. We'll work through this in a second to work through but in SAM, every file name must be unique. So you can't, there can only be one file in the whole DUNE hierarchy that's MP04 raw run data 5758.001 DL3.root. MP04 means it came from proto-DUNE. Raw means it's raw data. This is run number 5758, which was during the Beam run of proto-DUNE in fall 2018. And then each proto-DUNE run might take some number of instances and so forth. Now that file happens to be stored in 4 different places right now. Well, 3. NStore. NStore is at Fermilab. And this actually shows the tape label volume that it's on. CASTOR, which is at CERN's tape thing, and CERN EOS. So we kept this one on disk at EOS, which is the thing at CERN. Now, Sam is smart enough to know that if you're running at CERN, it should give you the CERN one. If you're running at Fermilab, it should give you the Fermilab location. If you're running in UK and the file happens to be in the UK, it'll give you the UK location. But it's not smart enough to cover every possible combination. We run at 36 different sites all the way around the world. But there is some intelligence there. Now, SAM queries use what are called dimensions. And this is very old syntax, dates from the Alta Vista search engine of the late 90s. It tells you how old it is. But there, you notice there's no equal signs in this thing. Run number 5758 and run type proto-DUNE SP and data tier raw. That would show all the files from that. And if you do that, you'll get quite a few. Now, data tier raw means raw data. Data tier full reconstructed means it's all the way reconstructed. And this is a very old reconstruction. This would have been reconstruction that we did while we were doing it. So these are the corresponding reconstructed files of that same thing. I truncated the output because, so the next idea in SAM is that you have parentage. So you saw up here, I have, oh, do I? Let's check that. So a RICO file has a parent of a raw file, and this can be a many-to-one relationship. So a RICO file you could reconstruct several raw data files and make one RICO file. Or in particular, if there's Monte Carlo, or if in the analysis stage you can have many different raw data files come into one file. You can also have one parent file make many child files. I'm going to just go here briefly to useful for doing SAM web parameters. Oh, great. Those of you who don't have Fermilab sign-ons yet, sorry about this. We are close to getting some of this computing stuff public, but I don't think it's public yet. File type, detector in Monte Carlo, run type, proto SP, proto DP. There's now also near-det. There will be far-det. There will be near-det subsource raw, full reconstructed detector simulated. Physics, cosmic commissioning tells and test. Physics and proto DUNE means we're running with Beam. All right. So, and if you look at, oh, come on, really? You're not gonna let me go back? Okay, sorry. All right. So what is the DUNE data.fnl.gov with some of the official data set definitions. So in SAM, anybody can make a data set. That's really one of the problems of it. You get so many data sets, wrong, you don't know what's whose. But the official data sets are at DUNE data.fnl.gov. That is public. So how do I find a file? I can do SAM web get file access URL, and that will give me something like that. I can do schema equals root. I can do schema equals HTTP. I can do schema equals GSI FTP. So the different schemas will give me different ways to access it. GSI FTP is otherwise known as grid FTP. That is being decommissioned all the way around the world. Within the next year or so, nobody's going to be able to do that anymore. But root anyway is what you're using in a job usually to read to stream a file. Root access gives the possibility to do streaming output. That's the strength of root. In a typical reconstruction, we read all the file, but maybe you're doing analysis and you don't need to read all the file. And root gives you the option to skip through and get only the branches you want, and really only get the data you need and not all of it. And that's much more handy in terms of rate of output that the storage element has to source. And it's also more handy, because, like I say, because you can stream. There is a wiki page here with much more data, but I think now let's take a little bit of time to try to do exercise 1. If there's questions on that, either raise your hand, throw them in chat. I realize looking at this exercise, it may be actually a little bit things. So let me work it through, and let me go to sharing my whole desktop rather, so you can see my terminal window, and I can still see the other thing too. All right. So I'm just going to first of all go back and do my DUNE setup the second it was done here.
Are you sharing your screen, Steve?
I thought I was.
You're not sharing anymore now.
Sure. Okay. Now I should be sharing my screen.
Yeah,
You
now we
it?
see your desktop.
Okay.
Excellent.
All right. Give me a second. So I'm sharing my whole desktop. We're doing the whole setup again. So this is a clean. This is a clean setup, just to show you. I just logged in clearly. All right. All right. What did I do wrong? Who can tell me? What did I miss? I know what I missed, but can somebody else quickly tell me what I missed before I get there?
I think you
Are you
need
guys
to
awake?
the DUNE TPC version.
I did not set my DUNE TCC version, so I'll do that again. So we're using what's called GSI proxy. So this sets me up with DUNE role analysis, as it should. Yes, okay. All right. So now I can do the things at the beginning of my exercise. Can everybody read that terminal okay, by the way? Is that a good font? Can people see what I've done? All right. So are you following along with me? So hold up if there's any questions here. So the next thing to do is going back to data management, and we say set up SamWeb client and export SAM experiment equals DUNE. So SamWeb client is not set up by the default DUNE setup. You have to set it up extra. Come on. I hate cutting and pasting. Why we don't do these live usually. All right. So now I should be able to SamWeb locate file. You notice there's two different commands here. SamWeb locate file and SamWeb get file access URL. So this is now beginning. If I do schema root here, the SamWeb locate file just gives me the logical places, Neos, Castor, and NStore. If I say schema equals root, it gives me the actual root URL. I can XRDCP this. I can do XRDCP and copy and paste that. Now, getting to the question of minus location, which is what exercise 1 says to do. If I add, it gives me only the NStore one, so I can. That's what the point of exercise 1 is about. So you see the minus location option here. You can add. Now let's get the metadata. Okay, in DUNE, we had a pretty open bucket for setting up metadata, and we didn't have a working database, so we threw a lot of crap into the data in metadata. But what does it store? Okay, it stores the file size, 8 gigabytes, stores the checksum, so we can see is it good or not. Tells us when was it created, November 2018. Shows the RDAC version that wrote it, raw data tier, physics data stream, which means we were running Beam at the time. The configuration, every single WIB that was in the detector at the time, it got awful, but this is what we had. We were hoping this does not carry through to real DUNE. But anyway, all that information is available there. Now, as pointed out, if I do, those of you who are more used to JSON, you can get it spewed out in JSON format. And that's what we've got here. So there will be a different metadata server by the time real DUNE runs, but the same idea will be there and the same kind of things will be stored in it. Now, when we're analyzing large number of files in a group of batch jobs, we use a SAM snapshot and create a SAM project based on that. So we have a data set called PDSP prod 4. So this is a data set of Monte Carlo that we just recently made in a big production. It's huge. Same web described definition. What this does, it has a name and then it has dimensions. So the dimensions are data tier is full reconstructed, file type is Monte Carlo, DUNE campaign is PDSP prod 4, and the beam energy is 1, and the space charge is yes. In version 90901, which is the DUNE TPC was made from, and using MC generators of beam cosmics. So that's how you define a data definition set. And in SAM, the data definition set will always be how many files actually match that criteria. And I can add more things to it later and it will get bigger. So SAM web list definition files will tell me all the files that are in that thing right now. It's a lot. And I have to think about it a while. It's that big. But now if I want to know how big is it, I can do, it'll tell me how many files are there, how big are they. These are all in bytes, megabytes, or kilobytes, megabytes, gigabytes, 52 terabytes of stuff in this thing. 27,000 files, 27,600, 10 events per file. So there we go. Now, you can see all the definitions that anybody ever made by huge number of definitions. You see there are a lot of them called snapshot, something. Whenever you see something snapshot, something, that's what's created by when somebody made a SAM project. So we're going to do a SAM web take snapshot. Normally, you don't have to do this by hand. When you create a SAM project, it will do that for you. But that will capture this data set as it is at this time, and then give me a static thing to run across. So there we go. So that's exercise 2. Now, I'm going to go now briefly. Are there questions on what I've shown about SAM up till now? The rest of it should go pretty quickly. So if there's any questions or if anybody needs help doing the exercises at this point, we can take a couple questions at this point. Everybody's very quiet. I can't see the doc. Hopefully.
There are some questions. Go ahead, Claire.
So far, no question on the chat, but yeah, as you are going to secure B, there are some questions in the live doc. Exactly. Yeah.
Okay. How do we set up Rusio? Okay. I'll answer the question how we set up Rusio afterwards. Okay, what's the difference between root and xroot? They're identical as far as I know, and they can be used interchangeably. But typically we write our URLs with root : , but the protocol is called xroot.
Root is preferred these days.
Yes.
But both will work.
People
I don't know if that will always be true.
All right, people seem to standardize on root. Yes. Okay. So back to the thing. So now we're sort of shifting gears here. There's more than data management we're covering in this particular section. I have until 10 o'clock, right, to finish this. So what is UPS and why do we need it? Okay. So in metadata is a good reason reason why too. You notice that we're saving the versions of all these applications we use. You need to be able to repeat the same calculation of the data. May Carol get the same answers every time. You may have to be reproduced a slightly different version of the plot. Data has to go into it. So, but if you notice, DUNE typically releases a new version of DUNE TPC every other week about. There have been several releases already this year. But there are already papers published out of DUNE from Proto-DUNE. We have to maintain not only the data files that made them, but also the software that made those data files. And so we have to keep binaries and versions. And furthermore, DUNE TPC depends on a lot of other subproducts below it. Most importantly, Larsoft, but others as well. And those are also changing. So we have to not only know what version of our software is but what dependencies do we run it with at any given time. UPS's Unix product setup. Some version of this has been around for me for as long as it's been Unix, which is at least 25 years now. There were versions of it for IBM and VAX before there was the Unix version too. So when you source or dot, if you see somebody using just a dot there instead of source, it's the same thing. And these are all using bash. Most of these have CSH equivalents if you really need it. The sourcing defines the UPS setup command, but setting up DUNE TPC, some DUNE TPC version, which for our purposes is, we're doing all this too with V092222. Okay. So whenever you have the setup command, you have the DUNE TPC, which is the name of the product, version, and then you have qualifiers. So typically most UPS commands include a product, a version name, and the qualifiers. E19 is the version of GCC that was compatible with. The prof means it's compatible with optimization turned on. You could also compile with debug. The flavor, I have not shown a flavor in this thing, but let's see here. Oops. So DUNE TPC is built for only one flavor, Linux plus 64-bit 310 217. Flavors are complicated. This is just a nice way to say Scientific Linux 7, which is the only version, which is the only operating system we support at the moment. It has in the past been available for Macintosh and other things, and maybe again. Now, so when you do that setup command, you get a lot of things. You get DUNE TPC dir. This is the top level of DUNE TPC. You get a setup command of DUNE TPC. You get the includes, which you need. The version, you get the lib, which are the libraries you include, and you get the SQ dir. Now, the products directory says where everything lives. So we have right now DUNE OpenScienceGrid.org, Larsoft, and Fermilab OpenScienceGrid.org. Those are the three products directory, but you can add any number of other UPS directories if you need to. Now, the main executable is Larsoft. So this tells me which version of Larsoft am I running. There'll be much more coverage of what Larsoft actually is in tomorrow or in the next day's tutorial. but these are the typical commands that you might want to do. Now, if I UPS list, if I show all the, oops, if I show all the DUNE TPC that ever has been, we've been doing this a long time already. Force said something. So how do we manage to not clean this thing out? This is a huge amount of data, right? I mean, DUNE TPC is already pretty big. One version of it is already pretty big. So, and if I show all the things that this depends upon, these are all the various products that DUNE TPC depends on. There's a huge number of them, and we'll go into more detail in tomorrow's tutorial on what they are and why they're there. Do people want, I think I need to push on and get through the rest of the content, and then we can come back if people are having trouble with the exercises, unless there's something at this point. Very quiet. Just a few words on MRB. MRB stands for multi-repository build. Why is this important? Thomas put a thing here. Any exercise with MRB takes about 30 minutes on its own. Takes long enough. Larsoft in particular is a huge package. It takes forever to build it. We have a DUNE build node that does nothing but build, and even that takes a long time to build the software. And so over the years, the software has forked into more than one Git repository. So Larsoft has got its own. DUNE TPC, which builds on top of that, has got its own. There's a special package just for proto-DUNE data, things that's on top of that, et cetera. They've all got their own repositories. And so if you're going to build software, you need an extra tool, and MRB is that. DUNE should have split more than it has. That's absolutely right. And there's no point in recompiling everything if you're only changing one thing. But more importantly, CVMFS, you've seen us using CVMFS already. CVMFS is sort of a weird little bird. In the early days, we would just put all, you saw there was a thing called DUNE Amp, we would just put all our software on there. And most of it still is there too. But there might be 10 gigabytes of code in a DUNE release, and maybe only 5 or 10 files change between one release and the next. So CVMFS stands for the CERN VM file system, and it was built originally for virtual machines. And the idea is that maybe you're checking out software, you don't even use it all. The CMS software stack is something like 500 gigabytes all told already. And on any one job, you're only using one version of that. You're only using some small part of that version. So why bring it all into your VM if you don't need it? And so CVMFS uses caching via HTTP. And it uses HTTP caching because people know how to make HTTP web caching work very efficiently. Say I have 500 nodes at one site. I can bring all of the software to a node at the boundary called the squid server. So you only have to fetch it across the WAN once, and then all the worker nodes can go to that local cache and get it from there. And furthermore, the way the jobs tend to work, we're using whole node scheduling most of the time. So more than one DUNE job will start at once. We'll likely be using very close to the same software. So if I fetch it into one worker node, I'll have that same software there for all of them. And so that is also making it so I don't have to copy a big tarball of software every time. So the main key of this is that it's got a deduplication feature. So some header in the software doesn't change ever. It's the same. It's the same. It's been the same. We only have to send one copy of it out. We don't have to store 900 copies, one for each version of DUNE TPC. So that just saves a whole bunch of amount of time of the data we have to transmit and cache, and makes it doable basically. The master for the DUNE software is here at Fermilab, and there are only certain software publishers who have the right to write to that. But it's read-only. There are 3 redundant publishing servers across the United States that are always there. So there's one at Nebraska, there's one here at Fermilab, and there's one at Brookhaven. So if one of them goes down, it'll automatically fill over to the other 2. And then there are similar ones over on the European side that pair with us, and they mirror our stuff too, and we mirror theirs. There's also a feature called Stash Cache or Xcache, and so we use this in DUNE. We use it primarily to send photon detector libraries across the thing. So when you're doing Monte Carlo, you don't actually do out every shower. You have some amount of stored things of how the photon is going to do it. That's the main thing we use it for within our own thing. And the other thing to point out, CVMFS is by its nature read all. So if you want to go to CVMFS/CMS at CERN.ch and peruse the whole CMS software tree, you can do it. It's out there. Or if you want to see the whole Atlas software tree, you can do it. It's out there. So this is, you don't put proprietary secrets in CVMFS. Don't put sensitive software in CVMFS. So for instance, the people that do the beamline simulations of Mars, they cannot put their software in CVMFS because there are sensitive neutron libraries in there and that's supposed to be exported. But otherwise, things can be in R stored in CVMFS. There's a lot more information there. So let's work exercise 6. Then we can go back to so I already logged into DUNE GCVM01, so it's going to show some stuff already mounted. Right, so somebody's ahead of me. All right. But typically, the only parts of CVMFS that are mounted are the parts you actually use. And if you don't know they're there, you won't even see them. So sometimes if you're on a machine nobody else is logged into, this CVMFS directory might be blank. You may not see anything. You may not know it's there. But say I want to go to okay, there's CMS. Now go up and it's still there. Typically, once they're mounted, they stay mounted for a long time. CD. Now I'm going to change down here. I'm just going to show you one other key thing here. Okay, so I can't read it. I can't touch it. I can't modify anything in there, right? These are read-only file systems. But oops. Tab completion is not working right now, which I'm not quite sure why. But anyway. Oh, I'm typing it wrong. I wonder. A bunch of garbage, okay, which I expected. But the point is that those files aren't there, it only caches them. And in the case of these big root files, it doesn't distribute the whole file, it just distributes the pointer to it, and then you read it at one at a time. So that's the main things to know about the stat cache, the DUNE OSG storage thing. And also, there are a few remote sites don't have this one, they don't mount this one. We try to get them to mount it all, but they don't all mount it. So I've got 5 minutes left. You have time to finish up the I guess there's one more point I should point out, and that is the direction that we're going is that anything that is on permanent storage in DUNE going forward is going to have metadata. Right now, it's technically possible to throw something into tape back directly and us not catch you, but within the next 6 months to a year, it will be that users will only have opportunity to write to the Dcache and scratch, and then you're going to have to use some declaration utility to declare your stuff, to declare the metadata of your file and the locations of your file to the permanent locations. So the direction that DUNE data management going forward is that every piece of data that's in permanent storage is going to have metadata that's going to be managed, and is also going to have a lifetime. Raw data is supposed to be kept quotes forever. I point out that if your experiment ran before 1998, Fermi, all of your data is gone already. So forever is not really forever. It will be long after I retire, but maybe not forever. Particularly, we'll only keep certain number. The data plan for DUNE is only keep certain number of simulations on disk at once. Only keep certain number of reconstructed data on disk at once, so forth. So simulation results, n tuples, or whatever, it needs to have a lifetime, and there's going to have to be a way you have to renew it if you want to keep it on, so that things don't live forever. Because every year the storage people show us a plot of, okay, this is how much stuff, how many files on the disk are 8 years old and haven't been touched at all. How many they're 10 years old and haven't been touched at all. DUNE has only lived for 6 years so far. We have stuff that's 10 years old, so it gives you a clue how long things have been going around. Any further questions, comments? It's very quiet.
Yeah, there is a question on the live doc. What is the
Okay.
meaning of to stream a data file?
Okay, that will be demonstrated in the next part of how to run a tutorial, but basically what it means to stream a data file is that you, on the command line, you say lar and reads from some file, root colon some file name, and it will read across the network the first block of the file, it will compute on it, it will read the next block of the file and compute on it, as opposed to copying the whole file to your local disk and then working on it locally. It's much more efficient to stream it because most DUNE software is not very IO intensive, that we do a large amount of CPU per bytes of IO, so that you can be fetching your next block while you're computing the first block, and it just requires less network bandwidth, and also is much kinder to the local disk of the worker nodes. Does that answer the question?
Thanks. Of course, Steve, after you can also go over the live doc and do another pass on the
Right.
answer for sure. Thank you so
Right.
much for this. I think that it's pretty much all the questions we had so far. Feel free among the participants, feel free to thumbs up. Thanks you so much,